Okay, we're going into the next section, 4.5. I was mislabeling a couple before these as 4.3 when they were really 4.4, but that doesn't matter as long as you watch them all. This one's on equations where you have to solve the equations, and there'll be either exponential equations or log equations, and we're going to start with the exponential ones. If you can solve it, fine. If you can't solve it, you change it from a log to an exponent or vice versa. In this case, it'd be an exponent to a log. And then sometimes the answer is very easy. I did this video just a minute ago, finished it up, had them all worked, but I forgot to turn the camera on, so I'm doing it over again. All right, let's start with the first problem up here. 5 to the x equals 125, what's x? Some of you probably know this already. How many 5s does it take to get 125? It takes 3. 5 times 5 times 5 is 125. But if you can't see the answer, then you change it to a log. And our base would be whatever has the exponent, so the base would be 5. Of, go over the equal sign. Equals, come back over the equal sign. X. Do this on your calculator. Log, put 5 in the little box, 125 in the big box, and you'll get 3. Now, the reason we can do this is because there's nothing in front or behind the 5 except for the exponent. If there's something here or here, you can't switch it. And we'll get to one like that down here in a minute. All right. Oh, here we have 2 bases, but they're both 5. And there's nothing in front or behind. If the bases are alike, the exponents are alike. So just drop the bases and say 2x equals x plus 1. Subtract the x, you end up with x equals 1. There might be one problem on the test where it's this pretty simple. If the bases are the same on both sides and there's nothing in front or behind except for exponents, then you can drop the bases and just write the exponents. You can't do that over here. I have no idea how many 3s it takes to get a 7. It's more than 1, but it's not 2 because 2 3s is 9. So it's 1 point something. But then they have x plus 2 up there. A little bit tricky. But if you change to log, it becomes very easy. What's our base going to be? 3. And there's nothing in front or behind, so we can do this. Base 3 of, go over the equal sign. Equals, come back, we're missing the x plus 2. Now do this on your calculator, but you don't have to write it on the paper. But I'm going to write it on the paper. And you will get 1.7712. Now you don't have to write this down, just leave it on your calculator. This is called an irrational because the decimals go forever. And then we're going to subtract 2. So just leave that there and go minus 2, and you'll get the final answer of negative 0.2288. And the decimals go forever. If the directions say 3 places or 4 places, you round off. If they don't tell you, then 2 places is good enough for me. Well, that's the top 3. Let's do the next 3. These are all natural log because they're base e. Let's change this to log, but we can't right now because there's something in front of the e. That's our base. There's something out here. There's nothing over here. And you can have all the exponents you want. What can we do to say we have to either get rid of it or move it or something? You can move an 8 up to here, and that'd be 2x times 8, or you can bring it over here, which is probably better. So let's divide by 8. Equals 20 over 8, and that reduces to 10, 5, 4 over 2. Now we can go to a log, and our base is e. There's nothing in front or behind it, so it's ln. You don't have to write the e. If you want to, you can. ln e of, go over the equal sign. Equals, come back, 2x. Now, before I actually do this on the calculator, I'm going to move the 2 over here. Equals 5 halves. I wrote that wrong. Let's just go and do it in the calculator. That'd be 0.9163. Equals 2x. And divide by 2. X equals 0.458. I was going to show you how to do the exact answer, but I'll do it on this one. We can go to a log, so see if you can rewrite that as a log. All right, base E of 4 equals 3 minus 2x. That's a 4. Let's not do this right now. Let's just move stuff over. So how do we move the 3 over? It's positive, so we subtract it. How do I move the negative 2 over? I divide it. So x is equal to this. That's called the exact answer. If I actually do it on the calculator, I'll round it off and we get an approximate answer. So this is called exact. Now let's do it on the calculator. Hit ln4, get an answer, subtract 3, get an answer, divide by negative 2. And you should get 0.807 rounded off. I'll say R. Those are both answers. If the directions say exact, if they say rounded off, this last one looks like a doozy, but it's actually pretty simple. We need to see what's in common. There's not a 3. There's an x in both of them. And there's an e to the x in both of them. So when you take out the x and the e to the x, we're left with a 3. Take out one of the x's, the other x is left, and e to the x comes out. We've got 3 things. We have x, e to the x, and a parenthesis. Any of those could give us an answer. Like, what makes this 0? Well, that one's easy. Negative 3 is one answer. What makes this 0? Well, 0 makes it 0. And what makes that 0? I'm not sure. So let's say e to the x equals 0. Change that to a log. It'd be ln of 0 equals x. And do that on your calculator and you'll get error. I hope you can read that, error. So there's no answer there. So the answers are 0 and negative 3, and you got an error on the middle one. All right, that's your introduction to equations, and I'll be doing some more examples. You can go to 4.5, the first section, and pick out a couple odd ones and try them.